So we're looking at some examples that use trigonometry. So we're going to look at the integral of the cosecant of 5x, cotangent of 5x, dx. So looking for the inside function, we can see that the 5x is on the inside. So we're going to let u is equal to 5x. Derivative of u with respect to x is 5. So du is equal to 5 dx, and then dx is equal to du over 5. Back in the problem, we have then the integral of the cosecant of u, cotangent of u, and replacing dx with du over 5. So bringing out the coefficient of 1/5, we're anti-deriving cosecant of u, cotangent of u. And the integral of cosecant cotangent is negative cosecant of u, and then plus the constant. So we have negative 1/5 cosecant of 5x plus the constant. Next example, we're looking at the integral of x sine of x squared dx. The x squared is on the inside, so we're going to let u is equal to x squared. Derivative of u with respect to x is 2x. So then du is equal to 2x dx, and dx is equal to du over 2x. The integral reads then x sine of u, and replacing dx with du over 2x. The x's then can reduce, pulling out the coefficient of 1/2. We have 1/2 the integral of sine of u du. So we have 1/2 integral of sine is negative cosine, so negative cosine of u plus the constant. So final answer is negative 1/2 cosine of x squared plus the constant. The next example is the integral of sine squared of x, cosine of x dx. Rewriting the problem so we can see that the sine of x is being squared. So sine of x is the inside function. So we'll let u is equal to sine of x. Derivative of u with respect to x is cosine of x. Du then is equal to cosine of x dx, and dx is equal to du over cosine of x. So back by the integral, we have the integral of u squared, cosine of x, and dx is replaced with du over cosine of x. The cosine of x is reduced, so we have the antiderivative of u squared du, which is 1/3 u to the third plus the constant, and bringing back in the value of u, so 1/3 sine of x cubed plus c, or it can be rewritten as 1/3 of sine cubed of x.